this example, they're giving us the sine of x, telling us x is in quadrant 3, and then they want us to find the sine of half of x, the cosine and the tangent of half of x. And they want fractions and square roots only, no decimals. Okay, so how are we going to do it? Well, basically, to find sine x, there we go, sine of half x, cosine half x, and tangent half x, we're going to have sine and cosine of regular x. How do I know? If you look down at the formulas here, I'll go down to the formula chart. For, here's the half angle identities right here. For sine of half x, cosine half x, tangent half x, we have to get cosine regular x, you see. And I'm going to use this one, cosine regular x. So I need cosine regular x to do this. So that's what I'm going to do. So, step 1, first we must find cosine of regular x. So how are we going to find cosine of regular x? Draw your triangle in the quadrant they told us, quadrant 3. From the origin to the x-axis. Remember these kind of things? So I'm going to draw this thing in the third quadrant. From the origin, not this way to the y-axis, right, but to the x-axis, right? This is the x-axis and the y. We've got to go to that. Y, you've probably seen me done this a million times now because the angles really start from 0. So really, there's the angle, the x angle. But we just stick it right here in our triangle. That's not really x. X really starts from 0. But we're able to just stick it in our triangle, and it's a reference angle for x, and all the answers will come out the same for sine, cosine, and tangent, as long as that angle x goes to the nearest x-axis and not this way to the y. If you go to the y, you'll get the wrong answers for sine, cosine, and tangent. That's why we do it, because angles really start at 0 degrees, but we want to put the angle right in here in the triangle. It'll work as long as your angle goes to the nearest x-axis. It'll be what we call an x reference angle, and all the values, sine, cosine, and tangent, will come out the same. All right, so step 2. Find two sides by the SOHCAHTOA. I've done this a million times, right? So this, here, let me back up. This is the opposite side from x. This is the adjacent. This is the hypotenuse. So what did they tell us? Sine is negative 5/9. Remember, SOHCAHTOA sine is opposite over hypotenuse. So this is opposite. This is hypotenuse here. So the opposite is negative 5. The hypotenuse is the 9. And by the way, this adjacent is going to be a negative number. Let me just stick in the sign right now so we don't forget later. Right? Remember how the signs work? From the origin, to get to this angle, you got to go back and you got to go down. Back is negative, a negative number, and down is negative as well. Back and down. Okay, so we got that done. Step 3. Find the third side by, the Pythag. A squared plus b squared is c squared. Let's do it. A squared plus b squared is c squared. C is this one. It's the hypotenuse. A and b, that's the negative 5, and the b, it doesn't matter which one you call A or b. One of them's got to be the negative 5, right, for these two sides. One of them's negative 5, and the hypotenuse is 9. So this is 25 plus b squared is 81. So let's keep going. Subtract 25 from both sides. Cancels it out here. B squared equals, let me use my calculator. I'm getting 56. Okay, and then square root it. Yeah, now square root of 56 can actually be simplified. I don't know if you remember that. If you break down 56, it's 7 times 8, and 8 is 2 times 4. And so that is the square root of 7 times 2 times 4, right? You don't need the 8 anymore. The 8 broke down. So 7, 2, and 4. In fact, actually that 4 can even break down to be 2 2's, right? You break down that 4 a little further, 2 2's. So anyway, b is the square root of 56 is the square root of 7 and then 3 2's. 7 times 8, right? 2 2 2 is 8. And what does that mean? Well, 2 2's in, send 1 2 out, and they're gone. Do you remember how square roots work? That's going to be 2 squared. And what's left over? 2 times 7, 14. So b simplifies to be 2 square root of 14. Do you remember that? How square roots do 2 in, 1 out? Think about it for a second. You know the square root of 9 is 3, right? What just happened there? Well, 9 was 2 3's, huh? 2 3's in, 1 out. That's what square roots always do. They're a 2-for-1 deal. Like, you know, when I teach algebra, I would teach my algebra students like shopping at Target. Things are on sale 2-for-1. 2 3's in, 1 3 out. So that is what square roots do. So that b simplifies to be square root of 2 root 14. All right, so let's put it up here, and it's negative. Remember, because we know it's negative because we put the negative sign right here. Negative 2 root 14. Was that what it was? It was 2 root 14, right? Yeah, it's a negative. This thing down here didn't tell us negative, but it was a square root, so it could be negative. Anyway, we know it's negative because of the direction, don't we? It's back and down, so it's negative and negative to get to that angle. All right, so they're both negative. We've got the triangle. Now what? Well, we can find the cosine of x. Right? All this work was to find the cosine, right? First must find the cosine of x. What's cosine of x? SOHCAHTOA, right? Remember SOHCAHTOA? So it's adjacent over hypotenuse. So the cosine of x is adjacent. Which side's adjacent? Negative 2 root 14, right up here, adjacent over hypotenuse. So it's negative 2 root 14 over 9, isn't it? So we got cosine x. All right, good deal. Now what? Now we're able to crank out these formulas. Let's take them one at a time. They all use that cosine of x. Here we go. Sine of x over 2. You can go look up the formula sheet here, and it's this, plus or minus square root of 1 minus cosine x over 2. So let's go write that down. So it's plus or minus square root 1 minus cosine x all over 2, like that. So that is plus or minus square root 1 minus. Now we got the cosine of x right there. It's negative 2 root 14 over 9 all over 2. That's a little messy, isn't it? So there we go with that. Let's see what we can do with that thing. Bring it over here. Plus or minus square root 1. Now the double negatives here, you know that's going to become positive. 2 root 14 over 9 all over 2. Now, what do we do when we got fractions over fractions? Remember, we've run into this several times. When you have fractions over fractions, what do? You multiply all the terms, top and bottom, by the LCD over 1, right? And what's the LCD? 1 of each type of term under a small bar. So we're looking here at the small bar. We don't care about the major bar. I'm talking about the small bar. We have a 9, and that's the only item under the only small bar, 9. So the LCD over 1 is 9 over 1. What do? I multiply 9 over 1, 9 over 1. You can just multiply by, when they're not a fraction, like here, you can just multiply by regular 9. It's the same thing, right? You have to multiply all the terms, top and bottom, though, don't you? So this means sine of x over 2 is plus or minus square root of 9 times 1, 9, plus, these 9's cancel. 2 root 14 all over 2 times 9, 18. Woo! Okay, now we're going to come back to the plus or minus in a second. Let me get the other ones, and then we'll get all the plus or minus signs in a second. Okay. Oh, by the way, you cannot. Another thing you might think you can cancel that. Nope, you cannot cancel. Let me write another note. So many important algebra lessons here. Cannot cancel two items added or subtracted. They are glued. Like Costco, that's my Costco rule. They are glued together, comma, so you cancel both or neither, right? You can't break the bond. You can't go to Costco and they have two milks glued together and just cut it with your scissors and say, thanks, I just want one. You can't do it. If you want to buy at Costco, you buy the whole package or you buy nothing. That's what the way pluses and minuses are. See this 9 and this 2, root 14, they are stuck together, a glue bond, meaning, see, well, I want the 9. Nope. If you got to take the 2 also, and the 2, you can't do them both, right? You can't, so you can't do either one. So you cannot do it. You can't cancel just the 9 and the 18. So we're done with that one there, other than the plus or minus in the front. We got to come back to that. Let's go on then with the cosine of x over 2. Go down, look at the half angle formula. Cosine x over 2, there it is right there. It's almost the same exact thing. So, in fact, it is the same thing. It just has the opposite sign in the middle. So, you know what? We could just jump to it. Let's do it. I don't want to do this whole thing. It's going to be plus or minus the square root of 9 minus 2 root 14. It's just going to be the opposite sign in the middle. See this sign and that sign. That's the only difference, right? Look down at the formula. See right here? Same formula. Minus, plus, only difference. And our signs actually switched because of the negative item we plugged in. Okay, now, last one, and then we'll get all the plus or minus details. Tangent x over 2. What is it? Let's go down and find the formula sheet again. Tangent x over 2. Now, I don't like to use this one. That one's hard. This one's better. See, why? Because you don't have to worry about the plus or minus thing. You can just do it straight. It's just sine over 1 plus cosine. Tangent of half, notice it's half an angle, is sine of regular over 1 plus cosine. Sine over 1 plus cosine. That's the easier one. Sine over 1 plus cosine. Let's do it. So it's sine x over 1 plus cosine of x. Now, we found all these. We know them. We've got them. We own them. Sine of x, what is it? Somewhere. They give us that in the beginning. Sine of x is negative 5/9. Sine of x is, where am I getting lost here? Negative 5/9, 1 plus. And what's the cosine? We did a bunch of work to find that right here. Negative 2 root 14 over 9. Okay, fractions over fractions, you know the drill. Multiply 9 over 1, 9 over 1, and just 9 here. And so tangent x over 2 becomes, these 9's cancel, these 9's cancel. Negative 5 over is 9. 9 times 1 is 9. Minus, plus and minus is just minus 2 root 14, because those 9's cancel, don't they? Okie dokie. So we've got the tangent of x over 2. He's done. He's completed. And we're almost done with these guys, except we don't know plus or minus. Well, to find out plus or minus, I'm looking right here and here. We've got to decide where x over 2 is. Remember that? Let's go back here. They told us in the beginning that x is in quadrant 3. X is in quadrant 3, right? So let me bring this down here for you. So x is in quadrant 3. What does that mean? x is between 180 and 270, right? Look at the unit circle. Let me erase what's already there and look at it. So quadrant 3 is between boom and boom, right? This is quadrant 3, between 180 and 270 in quadrant number 3. Okay, so x is, but we are talking about sine of x over 2 and cosine of x over 2, so we got to cut that in half. So if x is between 180 and 270, cut this whole sentence in half, right? Then x over 2, right? If x is between 180 and 270, then half of that amount is between 90 and 135. Where is 90 and 135? Here's 90, here's 180, 135 is right there. It's in this zone right here. You look at the unit circle, that helps you. Here's 90, here's 135. So there's where x is. So x is down here. X itself is down here in the third quadrant, but x over 2 is between 135 and 90. He's in quadrant number 2, isn't he? So x over 2 is right here. What does that mean about the sign? All students take calculus. So we're in the x over 2 is in quadrant 2. Sine is positive. Cosine is negative, right? In the second quadrant, remember the all students take calculus. Sine is positive. The other ones are negative. Cosine is negative. Sine is positive. Cosine is negative. So we go back and we go, okay. Sine is positive. Cosine is negative. That's how we determine those signs on the outside. And so now we've got it. There's the sine. There's the cosine of x over 2, and we've already got the tangent of x over 2. Write signs, write everything. Okay, so how did we do that? We had to basically draw the triangle in the third quadrant where they told us to, and do all the work with the SOHCAHTOA and the Pythagorean to find the cosine. Once we got cosine, we grabbed it and plugged it into the half-angle formulas for sine, cosine, and tangent, did a bunch of simplification, and then we determined the right sign by remembering what they said about x is in quadrant 3, which is between 180 and 270, divided through by 2. Found out x over 2 is between 90 and 135, second quadrant, so sine is positive, cosine is